Hello, this is Sumit Kumar Arse. Welcome to my YouTube channel. I am from DABB IIPS. My roll number is IT2K2487 and my enrollment number is DE2402295. And today we are going to see our internal 1 question number 4 of our NAD. Previous question we have seen in our old videos. Now we will see our question number 4. Let's start. What our question is saying? Compare the iterative methods of root finding. Okay, with comments on the reliability of convergence. Okay, now see, we have methods for finding roots. See, we have bisection method, Regula Falsi method, Newton-Raphson method, Secant method, and fixed point iteration method. Down in table you can see here methods, and we also have formula which you can see, convergence order you can see, and reliability. Okay, down we will talk in detail about them. So let's start first with our bisection method. Okay, so see what our bisection method says. This method says it is a bracketing method. It requires two initial guesses a and b such that f of a and f of b have opposite signs. Okay, guaranteeing a root exists between them. Okay, formula we have c is equal to a plus b by 2. Okay, so see, this is like that. If you have an equation, you have to find f of a and f of b, which is f of a or f of b, one positive and one negative, and by that your root will be between them only. Okay, so by formula c is equal to a plus b by 2, you will be averaging the roots and you will come closer to the root. Okay, let's see. In this formula, when you will put value and after your result you will put in f of x, which is f of c, and then you will see it is positive or negative, and what it will be you will replace by that a or b. Okay, so it works like that. And here you can see if f of c is equal to 0, c is the root. Okay, and if f of a into f of c is less than 0, root is in a comma c, set of b is equal to c. Okay, if f of b into f of c is less than 0, root is in c comma b, set a is equal to c. Okay, now see, here you can see the convergence and reliability. Order of convergence is equal to 1, which is linear. Error is held with at each step. Number of iterations needed n is equal to log 2 b minus a by e, and reliability here very high, guaranteed to converge long as the initial bracket a comma b, okay, contains a root. Okay, nice. Slow but okay, absolutely reliable. Okay, but it has also disadvantage, which is requires a valid brackets. Okay, move towards our next method, which is our Regula Falsi method. Okay, also called our false position method. Now see, it is similar to our bisection method, but instead of taking the midpoint, it uses linear interpolation between a comma f of a and b comma f of b. Okay, to estimate the root, this is also a bracketing method. Okay, the bracket is always maintained. Okay, formula you can see c is equal to a f of b minus b into f of a divided by f of b minus f of a. Okay, now see, in this formula you can see the bracket is updated the same way as bisection. Whichever side c opposite sign to f of c become the new bracket. Okay, as sign means by putting this value f of c, after finding value of c we will put f of c, and we will see the value is positive or negative. As what value our positive or negative, we will replace it by a or b. It is like that only. Okay, now we will see our convergence and reliability. Order of convergence is equal to super linear between 1 and 2, but can be very slow. Okay, if endpoint gets stuck, reliability is okay. Now reliability is high, always converge, but maybe slow. Okay, but but maybe slow, then bisection in one cases, okay, in some cases I mean, more efficient than bisection, okay, when f of x is approximately linear near to the root, okay. Now we will see our next method, which is our Newton-Raphson's method. Now see, Newton-Raphson method is an open method. It requires only one initial guess x0 and uses the derivation f of x, f dash x. To converge very fast, it is the most widely used root finding method, and it is like that: xn plus 1 is equal to xn minus f of xn divided by f dash xn, okay. Now see, this is like that only. Find the value of 1, I mean guess 1, find that near to our 0 and then put in our method and go further till our value repeats or closer to our root, okay. Now we will see our convergence and reliability. Order of convergence for this is equal to 2, which is quadratic, okay. Number of correct digits doubles each iteration, okay. Extremely fast near the root. Reliability is medium, may fail or diverge if 1 f dash x is equal to 0 or near 0 at any iterate, okay. It is like that only, and it requires the derivative of f dash x to be known, okay. Now we will move towards our next method, which is our secant method, okay. Let's see what our secant method is. Our secant method says approximates the derivative in Newton-Raphson's method using a finite difference of two previous points, eliminating the needs to compute f dash x, okay. Now we will see what it is. It is like xn plus 1 is equal to xn minus f of xn into xn minus xn minus 1, okay, divided by f of xn minus f of xn minus 1, okay. It is like that, okay. Now we will see what is its convergence and reliability, okay. So see, yes, order of convergence is like golden ratio. It's have similar to 1.618, super linear between linear and quadratic, and reliability is medium, requires 2 initial guesses but no bracket, okay. This is good. May fail if f of xn minus f of x minus 1 is equal to 0, because it will then division by 0, that here it fails. No guarantee of convergence, okay. It has advantage that does not require its derivative, okay. This is what our secant method is. Now our next method and last method is fixed point iteration method. So what this method is, let's see. The equation f of x is equal to 0 is written as x is equal to g of x, okay. Starting from an initial guess x is equal to 0, okay. We repeatedly apply xn plus 1 is equal to gxn, hoping to converge to the fixed point where x is equal to g of x, which is the root, okay. This is x of n plus 1 is equal to g of xn, okay. This is like that. See, in this for you have a equation like x square plus x plus 1. So first you will x square and then all value opposite, then find x from there. Now then you have that x, put x square and 1 there, then x here and last 1 here, all there, and from there you will take x and all back here and x from there. You will get 3 different x's like equation here, and you will put the values here and see that and you have to see that here where the value is our less than 1, and we will put 1, we will take that 1 where it is less, and do the operations there only. So see the convergence condition here. If method convergence, if and only if g dash x is less than 1. Yeah, that what I said. Oh sorry, I said that there we will do, but first we will find one derivative, then we will see it is less than 1 or not. Okay, near to the root. Okay, if g dash x is greater than 1, the iteration divisors the choice of g of x is critical and non-unique. Okay, this is what we talked. Difference arrangement of f of x is equal to 0, the different g of x function. Okay. Now see convergence and reliability for this. Order of convergence is equal to 1 here, linear, where g dash x is equal to less than 1. Okay, near to the root. Nice. Reliability here low to medium. Okay, convergence is not guaranteed, it depends entirely on the choice of g of x. Easy to implement, but the most unpredictable method is used as a foundation for understanding other iterative methods. Okay, this is what our last method was. Now we will compare our method by this table, and you can see this is our we will see our method, initial requirements, derivative needed or not, convergence order we will see here, guaranteed convergence speed, and best used when. Okay, so see first we will see our bisection method. See, in bisection method you will see initial requirement is f of a into f of b should be less than 0. Okay, here derivative no requirement, convergence order is linear, here guaranteed convergence. Okay, yes, and speed is slow speed, this is what, and best used when need certainly simple function. Okay, as Regula Falsi method, Newton-Raphson method, Secant method, and fixed point iteration method. You can see here this Regula Falsi methods requires f of a into f of b less than 0. Newton-Raphson method single guess x0 and f of x f dash x known. Secant method two guesses x0 and x1, and fixed point iteration single guess x0 and gx chosen. Okay, and now derivative only needed in Newton-Raphson's method. Order of convergence you can see linear, superlinear, quadratic, and here golden ratio this is minus 1.618, and here linear. Okay, in first two you can see here guarantee of convergence, and in Newton-Raphson's and Secant no, and in fixed point iteration condition g dash x should be less than 1. Okay, speed it is slow, moderate, very fast, slow, and best use you can see here. First we have seen, second nearly linear, it is smooth, good, this hard to compute, and this rearrangement possible. Okay.